Okay, this is lesson 3.3, the percent equation. The previous lesson we used the percent proportion. This is just a slight variation of that some of you may like. In the grand scheme of things, I would like for you to use the way that you are most comfortable doing. So if you think about the percent proportion that we had before, it was part over whole equals percent over 100. And this is a rearranging of that. However, you may notice that there's no 100 in this one. And so basically what it is this can be calculated. If you do this, it turns it into a decimal. And so if you take the percent and divide it by 100, you turn that percent into a decimal. Now, if you think about what dividing by 100 does, it moves the decimal 2 places to the left. So then the rest of it is just a slight rearranging, but this is a really good way of doing the problems. That's super fast. So if you're good at turning percents into decimals or decimals back into a percent, if you're finding the percent, then this method might be for you. So on this lesson, I want you trying to do your homework this way so that you can decide in the grand scheme of things which way do you like doing it better. Do you like the proportion or do you like this equation? Now, we have a second variation. This is like the Motley Eyes version here. On the problems that are really generic, sometimes it may not be obvious what's the whole and what's the part. So this is just a way of thinking about it. The percent of something is something. So the percent of the whole equals some part, while the percent of something is something. Before we get into any examples of using this little percent equation, I want to go through a few quick little things for you. So I'll kind of read this for you here. We have thinking of part and whole is great for story problems. For the generic ones where there isn't any sort of a story, I might do the is over of version. And if you look at this example that I have here, it works out super nice. If I gave you some generic question like 27 is 30% of what number, you don't know what any of those things represent. However, if you look at it, there's the percent. That's pretty obvious. And then the number that's next to the word is, and the number that I'm asked for is next to the of. So I know the percent, I know the is, and I can find the of. So that the generic form, it works really good on the questions where there's not really a story behind it. As far as using this one, the key thing is you will have to get the decimal form of the percents. You cannot use the percents directly. You have to use the decimal form of them. So when you're finding a percent, you'll get the decimal form and you'll have to convert it to the percent. If you're using a percent, you have to put it in as a decimal when we go to do these. Without any more delay, let's move on to an actual example here. So we have example 1, find the percent using the percent equation. So here we go. In science class, students compared their vertical reach, up to the top here, and height to see if they are proportional. So it says Maria is 60 inches tall and can reach 75 inches high. So her height is 60 inches, but she can stand there and reach up to 75 inches. And then here is the question. What percent of her total height or of her total vertical reach is her height? So look at that question. What percent, I don't know, of her total vertical reach, I do know that, is her height? So that question is telling me the equation. I don't know the percent. I'm going to call that P. So I'll start. The percent equation is percent percent times whole equals part, or percent times of equals is if I can take the question right here and just translate it, either way should work. So I am asked for the percent. I don't know what that is. I'm going to call it P. Then there's a time sign. What am I finding the percent of? Well, it says of her total vertical reach. And her total vertical reach is 75. So it's of 75. So the whole thing is 75 up to here. Or that's what they're asking me to find the percent of. The thing that comes right after the of her total vertical reach. And that's the 75. Is equals. And then either the part of it that we're trying to find, her height, or whatever is right after the is, which is her height. And her height is 60. So now we have P times 75 equals 60, and I can solve this just by dividing by this 75 to get P all by itself. So I'm going to do that. I'm going to divide by 75. And when I do that, I get P equals, and I type in with my calculator on, 60 divided by 75, and I get 0.8. Now here's the trick here. This is not the percent. This is the decimal form of the percent. So to convert this into a percent, I simply need to move the decimal 2 places over. And if I do that, I get 80%. So what that means is her height is 80% of her vertical reach. 60 out of 75 is 80%, or 80 out of 100. So you see, I did this problem really quick and got an answer, but then I had to convert this decimal form into a percent. If I know the percent, I can't put in the percent in percent form into this equation. I have to do this convert to a decimal. So the percent that you have in this equation is never the actual percent. It's the decimal form of the percent. Either you put in a decimal form or you get out a decimal form like we did on this problem here. So let's take a look at another example. And in the grand scheme of things, I don't mind if you use the proportion or the equation, whichever you get correct results with will work, as long as you're showing me what you're doing. So here we go. An elephant weighs 15,000 pounds on Earth. 15,000 pounds on Earth and 2,500 pounds on the moon. Shouldn't be a surprise that it weighs less on the moon because the moon has less mass, so therefore less gravity is pulling on the elephant. Now, why is the elephant on the moon? That's confusing. Anyway, assuming the weights are proportional, what percent of its weight on Earth is its weight on the moon? That question from here to here is the equation. What percent? I don't know. Times, what do they want me to find the percent of? Well, it's the weight on Earth. But look, here's the weight on Earth right here. The weight on Earth is 15,000. So it's some percent of 15,000 is, and that's where you put your equal sign, equals its weight on the moon, which it tells me is 2,500 pounds, so 2,500. So I have a some percent of times whatever I'm finding the percent of equals is. So the question, what percent of is the time sign, and then whatever comes after the of always goes right here. And then the is the equals, its weight on the moon goes over here. So now I'm ready to solve this since we need that 15,000 to go away so we can find out what P is equal to. I'm going to divide by 15,000. And I need to remember when I do this division, I'm not getting the percent, I'm getting the decimal form of the percent. So 2,500 divided by 15,000. And I get 0.16, and it's a repeating 6. So let's think about that. It's going to be a bunch of 6s, right? Because I need to bump the decimal 2 places over to get the percent. It doesn't say anything about how to round it, so I'm just going to round it to the 10th place. So I'm going to round it to 16 point, And then this 6 has a 6 to the right of it, so it's going to round up to a 7. So the percent is 16.7%. And so what that means is that elephant weighs 16.7% of its earth weight when it's on the moon. Again, I have no idea why that elephant would be on the moon, but this is equivalent to 1/6. So the Earth's and moon, the gravities are different. The moon's gravity is about a 1/6 of the Earth. I think that's actually somewhat true. I don't know the exact numbers, but I think that's pretty legit. So let's move on to another example. Again, it should be quick. Write the equation. Divide if your variable's over here. If your variable's over here, all you're going to do is multiply. So every problem is either a multiplication problem or a division problem, every single time. So let's take a look at the next example. So here we go. Many states have a meal tax that is proportional to the total spent on food and beverages. In one state, the meal tax is 8.44%. How much tax will a customer pay if the food and beverages total $54? So how this works is some percent of the meal is the tax. That is the equation right there. The of is the times sign, the is the equal sign, and then the percent is a decimal, the cost of the meal, the tax that you pay. So in this one, it's 8.44%. So let's think about that. 8.44 is the percent. I can't put this percent directly in here because in here we always have to put the decimal form. So to get the decimal form, I need to move the decimal 2 places to the left. So I'm actually going to put 0.0844 for the tax rate, or the percent there. Again, I have to put the decimal form. The cost of the meal. Well, here it says the cost of the meal is $54. Equals the tax. Well, it asks how much tax. I don't know what that tax is. I'm going to call it T for tax. And now, wonderfully enough, if your variable is already by itself over here, the only thing you have to do is do this multiplication. So I'm going to do 0.0844 times 54. And when I do that, I'm going to put my T on this side. I get a decimal number that goes past what I would probably want to have it at. This is what my calculator says, 4.5576, but it's a cost. You pay it in dollars and cents. So this is probably going to be rounded to $4.56. And I'm going to label that tax. And there we go. So on a $54 meal, 8.44% of that is the tax that they'll add on. And then you'll probably, hopefully, leave some sort of a tip as well. And those are typically percents also. So there you go. The percent of the meal is the tax. And what I like about this equation form is this is directly the equation. Percent of is times the meal charge is equals the tax goes over here. And I can get the equation very, very quickly. So let's take a look at yet another example. So example 3, use the equation to find the whole. Jane earns 5.5% commission on the selling price of each home she sells. So it says over here what commission is. Basically, it's an encouragement for salesmen or saleswomen to actually sell something. So when they sell something, they get a percent of what they sell. So like a realtor, if they sell a home, they get a certain percent of the value of that home. Well, some places do that. They earn a commission, like car salesmen. Some places do that. And it's an incentive to sell stuff instead of just walking around and not doing any work. So it is right here. Instead of a salary, some workers earn a percent of the value of a transaction, and that is the commission. So think about that. The percent of the value is the commission. Where's my eraser? Is that an eraser? Yeah. So is the commission. So percent of the value is the commission. There's my equation right there. The of is the times, the is the equals. The percent, I am given, it's 5.5%, but remember, we cannot put that in directly. 5.5%, I have to move it 2 places to the left. So I'm going to put in 0.055 for the percent. The value here, it's the value of the home, and it asks what was the selling price of the home. I don't know what this is. I don't know what the value is, because this 9,020 is the commission. So this 9,020 goes over here. And so I don't know the value of the home. That is the question. So it asks, what is the selling price of the home? Well, let's just call it X. And so I have something times X is 9,020. So I'm going to divide by the coefficient, or the number in front of my variable. And so again, every problem is either you're going to divide or you're just going to multiply them. There's only 2 options really. You're going to either divide or multiply depending on where the missing piece is. If the missing piece is on this left side over here, you're going to divide. If the missing piece is over here, then you're just going to multiply the 2 pieces on the left. So I'm going to take 9,020 and divide it by 0.055. And I get 164,000. So 164,000 is the selling price of the home. So that means that salesman, when they sold it, or saleswoman, it's a girl here, when she sold it for $164,000, she earned 5.5% of that. So that is her incentive. By making that sale, she earned $9,000 or $9,020. And again, that's just an incentive for her to sell a home rather than just go through the motions and not do any selling. Commissions are an incentive to actually sell stuff. And again, some places do that, some places don't. So let's do one more example here. This last one is about some jeans, I believe. This one, to make a profit, a clothing store sells jeans at 115% of the amount they paid for them. So let's take a look at that. 115% of what they paid for them is what they sell them for. So let's write that down. Some percent of what they pay is what they sell them for. And if we think about it, the store sells or buys jeans, they have to do what's called markup. They have to mark it up. They have to sell it for more than what they bought it for, or else they will be losing money. So some percent of what they pay is the selling price, is what they sell it for. So if we think of it just that way right there, percent of, this is times, is equals, the percent is 115%, but remember, we cannot put a percent directly in this form. We have to move it 2 places to the left. So I'm going to put in as 1.15 of what they pay. And look at what the question is. How much did the store pay? We don't know. We know, or logically, it should be less than 28. If they're selling it for $28, they paid less than that. They marked it up, and then they sell it for something more than what they paid. So we don't know what they paid. I'm just going to call it X. And what they sell it for, well, it says right here, it's $28. So I'm going to put 28 here. So 115% is the decimal of some unknown amount that they paid is the $28 that they're selling it for. So since my coefficient is 1.15, I'm going to divide by that. And so when I do that dividing, it's going to be dollars and cents. So if it doesn't divide nicely, I'm going to do some rounding, and this does not divide nicely at all. I get 24.3478 and so on. So let's see, to the nearest cent, that's going to be $24. $2.35. And that is the store's cost. So let's think logically about it. The store buys it for $24 and some. They sell it for a bit more than that so they can actually make a profit. If they sell it for this amount, they don't make any profit. In fact, they'd probably lose money because they have to pay their workers, they have to pay utilities and all that business. So this isn't like a price gouging sort of thing. That's how stores work. They buy a product for a reduced cost, mark it up, and then they sell it for a higher price. So they bought it for $24.35 and sell it for $28. So if you look at that, they're making about $3.50 each pair of jeans they sell. So there you go. So hopefully these examples will help you set them up. I think a lot of times if you just think about or write this part down right here, and then it's a direct translation into the equation, shouldn't be too bad. If this way is just totally confusing for you and you'd prefer to use a proportion in the grand scheme of things, that'll be perfectly fine. I just want you to give both methods a hearty go. So that is lesson 3-3. So hopefully you can get your homework problems dealt with appropriately there, and as always, ask questions if you do not understand.